Hey, what's up guys? Jake with Legacy 4x4 here again, and today we're going to be working on my CNC machine. And so like all things, we're doing a lot of overhauling, fixing some stuff that's broken, but the big thing we're going to be doing is I wanted to add a router to my CNC machine here so that I can either engrave wood parts and make plaques and signs out of woods for people for a little bit of side money, but also so I could do some light aluminum mill work or router work on this machine. My machine is more than sturdy enough to support a router. All I need to do is redo the electronics to support that next 5th axis on the machine, and then do some tidying up and change out the Z-axis a little bit. Anyways, you guys can see behind me, we've got a table full of parts, and you can probably hear next to me the 3D printer is currently printing out some parts for the enclosure. Today, in this video, we're gonna be redoing the enclosure, and I'm gonna try to give you guys a little bit better detail about how some of the wiring works and how this enclosure works. And I'm using mostly off-the-shelf parts that you can buy, aside from the 2 mounts that I'm 3D printing right now. Anyways, let's go and get started, guys. All right, so you guys can see back here that the Prusa is currently earning its keep, and it is printing out 2 different parts for the enclosure of the electronics case here. These parts aren't necessary. You could do this without using these parts. I have the 3D printer and I wanted to do it, and so I'm printing out these parts for this. These are going to be the 2 mounts that hold the 2 different Mesas, the Mesa 7i76E and the Mesa THC AD that I use to control my plasma cutter. These mounts are going to get those 2 control boards about 2 inches off of the ground of our enclosure here, and that's going to give it a little bit of extra airflow to keep those parts cooled and to hopefully keep it a little bit cleaner when it comes to doing the wiring and the installation. All right, so I kind of started this project without recording because I was just out here kind of playing with stuff and laying things out. All right, so the first thing that we have to do is we have to make the mounting points for all of these things. If you buy one of these NEMA enclosures like what I did off of Amazon, then it comes with this like plate on the inside of it that is removable. Everything that's going to mount into this enclosure is going to be mounted onto this plate, and then that plate gets mounted into the fully sealed NEMA enclosure over there. My hope is to make everything have its own mounts so that I can remove the electronics, kind of put everything onto this, plug it in there, and then install the electronics in place. That way I'm not trying to manhandle this into the case with all of the electronics on it. After this plate is to take over to the sandblaster and blast off all of this coating, and then we're going to powder coat it probably a black or maybe a gold color here in a few minutes. But anyways, let's go ahead and go get over to the sandblaster and clean off this coating so we can get it in the oven. All right, so I got that piece in the oven. It is currently baking at the 450 degrees that Prismatic Powder recommends for that particular powder coat finish. It should turn out nice and clean. Generally speaking, I try to always powder coat stuff. If it does fit in the oven, I try to do that over paint. I think it's a better, more durable finish. I also think it's a cleaner finish, and it's a lot easier to get right than it is to just spray paint something. So generally, if it fits in the oven, it goes in the oven and I powder coat it. Anyways, while that's baking, I figured I would explain to you guys kind of what we got going on here. So, like I mentioned at the start of the video, the original goal of this was to add a router function to my existing CNC. I'd love to have a machine that can do both things. I don't have the space in the shop to have 2 individual dedicated machines, so I chose to go this route instead. Instead of spending the money I would spend to build a router from the ground up, I also decided I would upgrade everything on my machine. So I'm going to be pulling that machine out here in a little bit, probably maybe in this video, maybe not in this video, but that machine's going to come out and it's going to get fully overhauled. I'm switching out the motors, I'm switching out all of the wiring, I'm switching out all of the connections, everything, as well as completely redoing my enclosure and my control software, which is the point of this video, is mostly just going to be the controller. What that means is this, I would not classify this as a budget way to build a plasma cutter. If you want a truly budget way, the very first plasma cutter I built is probably the cheapest you can do to build one yourself of that size, or you can go try to buy one on the open market. There are several examples out there if you don't want to do all the work. I'm using high quality, name brand, mostly made in America parts that are going to hopefully perform better than some of the other parts I had on here in the past. I've not had any major issues with the controls or with the drivers or anything like that I had on this machine previously, but I did have a lot of interference and I had some minor issues with a lot of it. A lot of it was really came down to not having the right type of connections, or me personally not doing as good of a job soldering everything up and cleaning up the case. To get away from that this time, I'm using a lot more off-the-shelf parts. It's a lot more expensive, but I hope it'll provide a much cleaner answer when this is all said and done. For power supplies, we do have a total of 4 of them, and I'll break them down individually here in a minute, but we're using Meanwell power supplies. You can buy these on Amazon if you want to use those. We've got the Gecko 201X stepper motor drivers. I went with these because Gecko drivers are well known and for the most part produce some really high quality drivers for CNC machines. These are also very small. So one of the other things was I had to build an oversized enclosure on that table the second time I rebuilt the enclosure, and it's not very clean and it didn't turn out very well. And so I wanted to have something smaller so I can use an off-the-shelf available NEMA enclosure that's going to do a lot better job of keeping dust and stuff out of it, because that current enclosure does not keep dust or anything out of all of the electronics. Upgraded the relays to a slightly different style, basically the same thing like what I currently have in there, same style 12-volt relay, but the difference here is these have a replaceable relay block and they come with a little mount for them like this. So if you followed it for a while, you know that I've had issues with specifically the plasma relay. I think it's getting interference or something, but the relays just burn out over time. My hope is that by having a replaceable relay, if it ever burns out, I can just pull it off and put a new one in there really quickly and easily, instead of having to mess with all the wiring, which is what I currently have to do on it. Got some heat sinks for the Gecko drivers as well, and a bunch of other associated random parts. As we start to lay out all these parts and start to kind of see how things come together, I will talk through better which part does which, how it all gets hooked up and connected, and then also why I made some of the decisions that I made for like the number of power supplies, the size of the power supplies, and things like that. But anyways, that part should be just about done at this point, so let's go and pull that out and see what it looks like. All right, so I skipped a few steps. I didn't want to show you guys just me screwing all these things down into place, but let me go ahead and orient you to this board here that we have. So on my left here, you can see that I've just got some DIN rail. This is just a 12-inch piece of DIN rail. You can buy it on Amazon or wherever, and it's what the power supplies will mount into. You can see on the back of the power supply, they have a DIN rail adapter already, and they will just mount into there in a row. On the bottom of it, we've got another like 4-inch piece of DIN rail. That is what these relays mount onto. I chose to go with DIN rail because it's just a cleaner, simpler mount, instead of like what I did on the other enclosure build where I had to like build a complex mount to hold the power supplies. This is a much cleaner way to do this install, so I went with a DIN rail there and for the relays. Along the far right, you can see the heat sinks. These are for the Gecko drivers. So you can see I've got 5 of these total drivers that are going to be mounted along these heat sinks here. I got 5 of them to control the 5 different axes of the machine, the 4 motion control axes, and then the 2 different Z-axes. These will mount just on top of these like that, and I've got the screws for those in the box. And then these are the 2 pieces that we 3D printed. I got 1 big mount and 1 small mount for my 2 different Mesa boards. You can see I've got one of my spare 7i760s here, and it fits right on top of those mounts, and I'll just use some really small self-drilling screws to drill into the plastic that we 3D printed to hold the board into place. The idea of doing all this, to have all these mounts on the board, was so that I could have the board finished and I can install the board into the case without having the electronics on it, and then I can come through and I can do the electronics on top of it into all these different screws or onto the DIN rail cleaner without trying to lift the whole board with all the electronics on it like I had to do with the last one. So this is this. Moving over to the case, we've got to start installing the inlet for the power to run the power supplies and the main control switch. I've already got those installed, so I'll roll you guys over there and show you all that. So this is what the case looks like. Again, this is just a NEMA enclosure that you can buy on Amazon. It is a 16 by 16, I think, if I remember correctly. I'll verify the measurements here in a little bit, and it is 8 inches deep to support the space for all of the different electronics. On this side, I have my rotating power switch. This is just a little $15 one you can buy on Amazon. And then down here is going to be the primary power in to the case that runs the different power supplies and runs the control boards. Up here in this little opening, there's a panel, and on that panel is where we're going to mount the connectors for all the different motors, for the 2 extra relays for other auxiliary pieces, and then for like the plasma connection. All that stuff is going to go on this plate here, and then this wall is just for the power supply. Next thing I'm gonna do is I'm gonna clean this out. I'm gonna mount that board into place on here and start kind of laying some things out, make sure everything fits properly. All right, so as we wait for the 3D printer to print a couple more parts for this case, and as we wait for some more of the electrical connectors to come in the mail, hopefully in the next couple of days, I figured right now I will just show you guys what this looks like and kind of explain some of the different parts and kind of how they're all gonna function together before I start throwing all of the wiring into this thing. All right, so starting down here at the bottom, you can see the 4 different power supplies. For this, I'm running 2 different 48 volt power supplies, a 24 volt power supply, and a 12 volt power supply. Based off of the Gecko drivers and the calculations that they have on their website and the motor choice that I selected for this rebuild, 2 48 volt power supplies will provide adequate power to run all 5 of the drivers. So these 2 power supplies are only going to be used to run the Gecko drivers and the subsequent motors on the machine. Down here, we have the 24 volt power supply next to them. This power supply is only to run the Mesa controller and all of the switched inputs. It doesn't run any of the relays or anything like that. It simply runs the Mesa's field power, and then like the limit switches and stuff like that. So the controller gets its power from the 24 volt. This 12 volt power supply is exclusively used to turn the plasma cutter on and off again. The plasma cutter relay needs exactly a 12 volt power supply in order to function. One of the things with the last machine was I kept blowing the relays, and I can't decide if the problem was either interference from the plasma cutter itself or because I was pushing like 24 volts into that relay and over time they just blew out. So on this one, I'm running a 12 volt power supply to run that relay. The spindle does not need a power supply on it because the VFD for the spindle is where that draws all of its power from, and the outputs for the spindle come from the Mesa itself. The other 2 relays down here are going to be 110 volt relays, and they're going to be used to control auxiliary systems in the event that I eventually hook up like a dust collector for the router or maybe a water pump if I go up to one of the bigger spindles that are water cooled. So I'm putting these in here right now just so that they're already in the case and it's kind of all fit and ready to go for that, but I'm not planning on using them at this moment. For those 2, because there's 110 volt relays to run 110 volt systems, those are going to need to have 110 volt of power drawn into it, and you'll see when I make the faceplate at the top there, I'm going to have 2 inputs, 110 volts a piece, specifically to run those 2 relays. Right here we have the THC AD, and then next to it we have the Mesa 7i76E that I use to control this. That Mesa has plenty of inputs and outputs and spindle control, as well as enough control ports for 5 different axes of controlling motion, and so that's going to work perfectly. I've used it in the past, and I'm just going to use the same one from the last build of this table. This is the Mesa THC AD-10, and I'm using that THC to control the torch height control of the plasma table. So what this does is this takes a voltage from the plasma cutter, reading through the 50-to-1 voltage divider, and it takes that input, turns it into something that the Mesa controller can read, and then LinuxCNC is able to control the up and down motion of the torch based off of the voltage that is received through the THC and into the Mesa. Like I said, we got the 3 relays over here at 12 volt and 210 volts. We have the main power switch. This is just a rotary switch you can get on Amazon. Down here you can't really see it, but on the back side of this is the main power. This is where power for the power supplies will go into the case, to that switch, and then to the different power supplies and up to the control boards. We have the 5 different Gecko drivers at the top of the case. As you can see, I used the label maker and I labeled which ones are which. We've got the X-axis, which is the left and right movement, the 1 motor. We have the 2 Y-axis motors, the Y left and Y right. We have the Z for the plasma and the Z for the router. And that kind of completes the case. Lastly, we do have a fan. It's just a 12 volt DC fan up in the top corner of it. That will blow air into the case to provide the cooling, and then I'm currently 3D printing out a vent to go on this side that will allow the air to push out away from the case and keep the dust to a minimum inside there. So that kind of completes the case. And then lastly, of course, I adorned it with a Legacy 4x4 sticker right on the front. Now, coming up soon, once I get the rest of the parts in the mail, I have to make this faceplate. This faceplate is where all of the different connections are going to be. So there's going to be the 5 different motor connections, the 8 different limit switch connections, and then the relay connections for the dust connector and things like that, as well as the inputs for the plasma cutter and a bunch of other stuff. So we'll get into this next once I get these 3D printed parts out and installed onto this case. But so far, this thing is looking pretty good. All right, so moving right along with this project, I've got some of the case done, and I'll show you guys what the inside of the case looks like here in a moment. But I need to make my faceplate. This is a faceplate. It came with the case already removed and everything like that. And what I did is I drew up on Inkscape the way I wanted this to be laid out, and then I just lasered it onto the front of this that you can see there so that I have a place to mark. So now I'm using that laser basically to just mark out where all these holes need to be, the size of all these holes, and kind of the spacing of everything so that I made sure it all fit perfectly. Now, when I'm done with this, what I'm gonna do next is cut all of these out, all of these mounting points out, drill out all the holes, and make sure all of the associated connectors fit properly onto the faceplate here. And then after that, I will, once again, sandblast this thing completely clean, and I will powder coat this a different color, and then I will laser it one more time so that I get all of my labels and markers on this. It's just an added touch that I'm adding to the machine because I have the laser, and by having those markers and labels on there, it's gonna make it a lot easier to troubleshoot, say something were to happen, and it's also gonna make it a lot easier to just plug everything up and keep the machine up and running. Anyways, we got the faceplate marked out from the laser. Now it's time to just cut out all these things. I'll use the Dremel and the drill to cut out all these holes. So let's get to that next. All right, so I got all of those holes cut into that faceplate there, and I went ahead and just powder coated a base layer of this Prismatic Powder's Gold Tastic. It's kind of like a metallic-y, shiny gold color. I'm either going to keep that color and then I will laser off the etching of it to leave the bare steel beneath it when I go laser on the emblems here in a minute. Or more likely, I really want to try something else, and that is to do a second coat of powder coat on top of that Gold Tastic color with just a flat black, and then laser off the black, leaving the gold as all of the labels for the machine's connectors. I think that would look pretty cool, and it's also something that I have not done before. I've never tried to laser off one coat of powder coat, and so I'm thinking I might want to try that just to kind of get some more experience with the laser. If you guys haven't noticed, as I've been building this machine, I'm trying to take use of all of the other cool tools that I have sitting in my shop here, such as the 3D printer and the laser and a bunch of other stuff, in order to make this as clean and functional of a control box that I can possibly do, which is definitely a step up from the past ones, which have always been kind of just hand done and quickly thrown together. This one I'm trying to be very deliberate about and make sure that it comes out perfect. Anyways, we got that sitting in the oven, and I'll show you guys what that looks like here in a second when it comes out. All right, so while we got that stuff in the oven, I figured I'd show you guys what I have wired up in here so far. Really all I've wired up is the basic power wires and the THC connection, and that's about it. So you can see on the back side of our rotary switch here, I just used a piece of, I think this is 8.3 Romex. Doesn't really matter, I had some of this, just a little chunk of it, so I used a little bit of it to wire up the main power connector from our plug back down here in the bottom left. I haven't done the power wires to the actual power supplies yet because I actually lost power while I was doing this, and so I couldn't use my soldering iron, and so instead I just did the stuff that didn't require that at all. Coming from the power supplies, you can see this far right power supply here, this 48 volt Meanwell power supply, is being utilized to run both of the Y-axis motors. The one next to it is going to run the X-axis and both of the Z-axis motors. The reason why I have that one wired up to 3 motors instead of just 2 is because both of these Z-axes are not going to be actively used at the same time. Only the plasma or only the router will be used at any given time. So really what that means is these two 48 power volt supplies are both only running 2 drivers at any given time. When I did the math for this, that is what Gecko said it needed based on the motor size that I am running on this. We've got the 24 volt power supply is wired right into the Mesa's 2 different power supply pins, the orange pin here and the far right green one here. And then we've got the 12-volt power supply is not yet wired, but it's going to go to the plasma relay. On the back of the THC, we have the back of the THC wired for its plus 5 volts ground, and then the different inputs that are necessary for the controller, and that is wired into the Mesa over there. So coming up next, when I get that faceplate done, I've got to wire the faceplate into the different Gecko drivers here to connect the different motor drivers through the faceplate. And then I've also got to connect the Mesa to the Gecko drivers as well to provide the input data for that. And then you got to connect the THC, the Ethernet, and all the other small stuff. And I've still got to wire up the fan. I am drawing up a complete wiring diagram for this, unlike the last ones, and I will make it look nice and pretty once I'm all finished, and I'll host it up on the website when this is done. But this is where we're at on this. All right, so I got that part out of the oven, and it is now laying on top of the laser here, as you can see. I'm gonna try to scratch off just that black paint, leaving that nice gold finish on the underside of it. To do this, because I've never done this before, I'm gonna run the laser at about half power and just one pass to cut through it once, and we'll see how the result looks. And if I feel like I need to go through again, either with more power or less power, then I'll run through it a second time. But anyways, let's go ahead and get started. All right, so this is gonna take it quite a while to cut through this because I'm filling in all of those letters as it goes. It also smells quite bad because it is burning off that powder coat. So I'm gonna turn the camera off and I'm gonna walk away from this thing and let it just cut while I am far away from it. Anyways, I'll catch you guys up and I'll show you guys what this looks like afterwards. All right, so here you guys can see the faceplate. I'm not really sure if you can see the etching on there. It came out okay. I probably could have done another pass on it to make it a little crisper, but you can read it, and I'm happy enough with the way this looks. You can kind of see the gold there, or hopefully you can see that in the camera lens, how it kind of cut out what each of these different parts of this faceplate are. I don't have the emergency stop switch or the THC installed into the faceplate yet because I don't know what kind of plug I'm going to use for those yet. So I'm going to install those later on, but this is what everything else looks like. A whole bundle of wires off of the back. So for this build, I did choose to use a off-the-shelf commercially available wire pins. These are all from Avid CNC, who I've used a lot of other parts on this CNC build from. I decided to upgrade to their wire pins because it has the pigtails already on it, and all color coded in accordance with their motors, which I will be installing on the CNC machine in the next video about this. But the biggest thing is like these pins, like these little microphone type pins, these DB pins, and then whatever kind of pins these are really hard for me to solder. I don't know why, maybe it's just my attention to detail, or maybe it's just my big fat hands, but I can't get in there and solder them really well. And some of the issues I was having with the machine in the past was that those solder connections would break off. And so what I've chosen to do is just buy these commercially available options. These little pins are not that expensive, truthfully. The motors are, but everything else is pretty reasonably priced. So I did upgrade all those just so that I have a cleaner install and I have the guarantee that these are not gonna break on me like something that I could do myself. So I thought it was worth the justification when I was upgrading my machine. Anyways, the next step to this is to get this faceplate installed into the box itself and then start connecting all of these wires to stuff. So I'm gonna go ahead and install this and start connecting stuff, and I'll catch up with you guys when I have a little bit more progress done. All right, so as you guys can see, after you get the faceplate installed with all those pigtails, this definitely looks like a mess. My recommendation as you do this is to do one thing at a time. So start with like your motor drivers or start with your limit switches or something. Just kind of work your way from left to right, starting with one thing at a time, and slowly but surely you will knock this out. I know that this looks like a lot, and it is kind of a mess, especially with all very similarly colored wires in here, but there really is no secret other than just kind of taking small bites of this one just through and through. I'm gonna start wiring this up, but here you can see what the faceplate looks like mounted onto the top of the case here. Also, another recommendation, I should have gotten a bigger one of these cases. This is a 16 by 16. I was trying to be cost effective and I got one that was like $130. I should have stepped up to like the $200 or $230 ones that are like 24 or 20 by 20 kind of size. This is big enough and you can definitely make it all fit in here, but wiring it is gonna be a lot harder because I don't have as much space in here to work, and I'm gonna have to like kind of like tighten myself in there to try to get some of these connectors to go in. But this is what we got. I'm not redoing this, so this is how it's gonna be. But anyways, I'm gonna start wiring things up and I will show you guys kind of what it looks like as we go and where different connectors go. Figured I should show this. This is the first time I've seen this much snow in North Carolina in a few years, and the first time in my dog's life she has ever seen snow. So I figured I'd just record this for a little prosperity's sake, but looks weird. Looks weird. All right, so I figured I would show what my connector cables from the Mesa to the Gecko drives look like. So when it comes to wiring up the Gecko 201, like most other Gecko drivers, they are only a 3-wire hookup. The Mesa actually has 6 available ports on the control board for each of the individual motor drivers. The way you hook it up is you're going to use step negative, direction negative, and the plus 5 volts from the Mesa from each of the pins. Each of the pins on the TB2 connector on the Mesa board have one of these quick disconnect things, these little green quick disconnects. And you can see that I'm only using 3 of them. I'm using the negative for step, the negative for direction, and then the black wire here is the plus 5 volts DC. This then plugs into the TB2 connector on the Mesa and then is ran over to the Gecko driver on the other end, and then these ends are screwed in on the Gecko driver into direction, step, and common respectively. So this is the way this is supposed to be wired according to 201X user manual and also through the Mesa user manual itself. I did verify all this on the forums as well, and this is 100% accurate for how this is supposed to be wired. Now, when you are wiring up the TB2 connector, like I said, there's 6 individual pins on that long board for each of the different motors. And each of the pins has one 6-pin quick disconnect. So I'm doing them one at a time where I pull one out, I wire it up appropriately, and then I plug it back in and I wire it into the Gecko. This way I know which board goes where, and that is crucial when it comes to setting this up in the Mesa configuration file, which I will be remaking that video when I come up to redo all of the stuff for this machine here in the future, because I know that video needs a little bit of updating. But anyways, this is 4-wire shielded CNC specific cable. I didn't buy any 3-wire, I only bought 4-wire, and so all I've done is I cut one of the spare wires out, trimmed it down, and then I just threw some heat sink on the end there to clean up the look of it and to keep that wire completely capped off. But anyways, we're making quick progress. I'll show you guys what this looks like when I'm done. All right, I know it's hard to see inside the box, but truthfully, even if you could see super clearly in here, it wouldn't help. But what will help is I will draw up this wiring diagram and I'll host it on the Legacy 4x4 website so that if you'd like, you can download it. It's gonna cost like 99 cents, but that's just to cover the cost that it has to host different documents on the Squarespace type websites. Anyways, you can see kind of what we got going on here. I've got all of the motor drivers connected to the Mesa board and all of them connected to their panel switches on that faceplate there. So the motors should be 100% ready to go, all wired up. I did use that shielded CNC cable to connect the wires for the motors from the Mesa, and then use the attached pigtails to the back of the Avid CNC connectors to connect the Gecko drives to the panel switches on the faceplate there. Next up, I'm going to start working on the limit switches. You can see that we got all the limit switch wires here. I figured this is probably the single most number of wires, so I'd like to get these all finished up and plugged into their respective ports on the Mesa so that I can just knock those out and be done with them really quickly. So anyways, I'm gonna start wiring those up and get those out of the way, and then we'll come back through and start tidying up the last few things like the main power connecting, hookups to the different power supplies, as well as the, let's see, we've got the THC switch, the spindle switch, and the emergency stop switch. All those are coming up soon. All right, so I got another quick tip for you guys. Make sure as you work on this that you periodically check to make sure the systems are working as they're supposed to, specifically with regards to your power. So once you hook up your power supplies, as you start to connect more and more things to them, make sure that you periodically just turn the system on and make sure you get green lights everywhere like you're supposed to verify that the system is working. So I just did one of those little checks here, and I found out I had a short across the Mesa board because 2 of the wires decided to touch tips on the end there, and it shorted out across it, causing me to lose a power supply. Now, I was able to save the power supply, it all works as it should now, and I was able to quickly identify the problem because I was able to stop and do it one thing at a time. I knew what I had just hooked up, I knew the problem had to be with that, and so I was able to fix it. If you were to put this entire case together, and then you come up with 1 or 2, 3 error codes as you're going through it, it's gonna take you a lot longer to try to figure out where those error codes are coming from than if you had just done periodic checks throughout the build process. Anyways, we got this thing coming along nicely. I have all the power supplies all wired up. I've got the fan wired up, and you can see when I flip my switch, the fan starts to spin. The 4 power supplies all have their green OK lights on them, and you can see the lights on the Mesa board and on the THC as well light up, saying that they are functioning and they're in an OK state right now. You can also see the positive green lights on the Gecko drives, showing that they are properly energized and that they should work as they're supposed to. I will hook up the motors in the computer to this later on to double check that all those work once I get a little bit more wiring in here. Now the last thing we have left to wire on this thing is going to be the relays. I've got to go double check how to wire these DBDT relays, so I'm going to go look at that and figure that out and then wire those up, and then this case should be just about finished. Alright, so I've done a bunch of stuff in this, and I'll show you guys the case here in a second and where we're at on it, but first I want to describe how these relays work. So it did take me kind of a lot of figuring out and testing with these things to see if I can get them to work properly. I'm just not an electrical engineer. My degree is actually in mechanical engineering, so this is not exactly my forte. So I just did a lot of testing until I was able to figure out exactly how these things work, but I think I've got it down now. Obviously, if you're watching this video and you know more than me, please let me know in the comments down below so that I can correct this before I get into further testing. Anyways, I've got this thing wired up in a testing configuration on the table here. I have a 5-volt power supply down here at the bottom, and that 5-volt power supply is going to mimic what the Mesa 7i76E does. The Mesa 7i76E pushes out a 5-volt signal for its outputs, so by using a 5-volt power supply, I can confirm that it will trigger the relay and will hopefully result in whatever it is I'm trying to do. I've got a 24-volt power supply here because I just had one, and I'm using that to signify the load or the load power. And then I've got a little green diode here, right here, to simulate turning the torch on or off again or activating whatever relay you need to activate. So, push you guys back a little bit there. All right, so basically, the way this works is there's a total of 8 different pins on the relay base. I've got another one of the relays here, as you can see. Pull off the actual relay. So this is the relay base that you're going to be using for this, assuming you're copying my design exactly. These bottom 2 pins down here, next to that little orange pull tab, those are where the coil goes. And so that's what's actually going to signify for the relay to change its state. On the right, on pin number 13 is where you're going to put the common ground, and then on pin number 14 you're going to put the signal, the 5-volt signal coming from your control board. In this case, it's a 5-volt signal from the Mesa. On these 2 pins up here, pins number 12 and number 9, these are your common pins, and so that's where common goes. And then on the other side you've got the remaining 4 pins, but the ones we're using are going to be pins 8 and pin 5, which are these 2 pins up top here. These are the normally open pins. You can run 2 different circuits on this if you want to. I'm only using this to run 1 circuit, but you can run 2 different circuits up here if you need to or if you want to. When it comes to doing the rest of it, you wire it up according to the wiring diagram that I'll show you in a second. And when you go through to provide a signal, you can see that the LED lights up because the relay has changed state. That LED light, or whatever your load is, one side of it is wired into the normally open on the relay base, and then the other side of it is tied into whatever power supply it is. So for the plasma torch, it's a 12-volt power supply. For my 110-volt relays, it's a 110-volt power supply. Either way, you tie one end of those together, like so. The other end ties into there. That'll make more sense when you see the wiring diagram, but the basic idea is here. I got the relays to work, and that's what we were shooting for. It took a lot of figuring out to make that right, but we got it, and now we can go ahead and install these. All right. On the rest of the case here, I wired in the spindle switch and the emergency stop switch, so those are all wired up, and I made a couple of loose wiring harnesses that have the microphone connector on one side of them to plug in. So this is for the spindle, so when I get to eventually wiring up the VFD, this is what's going to wire to the VFD. And over here I have the emergency stop switch. I chose to just use a loose emergency stop switch so that I could elect to move it around if I want to put it somewhere else. Maybe I decide that it doesn't work where I have it placed and I want to move it, put it on the front of the table, put it next to the computer, whatever I want to do. So I made this nice long, about 8-foot long cable. Again, it's got a microphone plug on the other end of it. These are 6-pin microphone plugs, and they plug right into the microphone adapters on the faceplate of the control box there. So this is modular, and the spindle plug is modular as well if I feel like I need to move them around to better fit things or to get things to work properly. So So I got those done. Everything else on the case is plugged and wired. All I've got to do left is connect all of the relays and actually connect the spindle controls to the Mesa board itself. On this side of the case, I did also put in some LED diodes, similar to the ones you just saw me using on the testing of the relay. I'm going to add probably 2 more diodes to this side of the case as well to show the status of the relays. But for now, these show the statuses of the power supplies. So, if you're to plug this in, make sure everything's okay, you can see when you switch it on that all 4 of these relays or these little diodes light up. I know it's hard to see in the camera from where you're at, but this shows that all 4 of the power supplies are properly functioning. It's kind of more like just a status check for me, so that as I'm using the machine, I know if I lose a power supply, if something overloads, if something shorts out, I can quickly identify which ones are broken or which ones need to be serviced appropriately. I'm going to add those for the relays as well, so that if I ever notice that a relay light doesn't come on when it's supposed to, then I know which relay is it that went bad or which one needs to get replaced. Again, the whole reason why I'm using this style of relay is because it's replaceable without having to do any wiring. So you have just the relay case, it pulls out off of the base can stay inside of the control box there, and I can just quickly plug and replace the relays as necessary. Much easier to do than if I was trying to have to like get a little screwdriver in there and rewire everything, so that's a lot easier for me. So I'm going to add a couple more relay lights onto that, and then that should pretty much finish up this case. I'm going to get to working on the rest of this, and then I'll give you guys a walk around of the full case, talk about some of the wiring and some of the more complicated stuff, and then I'll show you guys some of the wiring diagram. All right, so there we have it. I actually have this all finished up. I got the relays wired up. I've got everything else completely wired up, grounded out to where it needs to be grounded out and done. And I just did a 10-minute run test of it where I just had it turned on and I let it run for 10 minutes. That way I could tell if maybe I accidentally shorted something, if anything smells weird, looks weird, smoke, all that kind of stuff. I could see it while it's on the table and I can easily fix it pretty quickly. So with the test done and with everything else finished, let me go ahead and show you guys what it looks like in here. I do have 1 relay left to wire, but I'm waiting for it to come in the mail. I accidentally bought 1 less than I needed, but everything else is completely finished, and when I get that relay in the mail, I will wire it up real quick and throw this on the table and start working on the mechanical upgrades. Anyways, so let's start out with the exterior of the case. On the front control panel here, you can see that at the top we have a vent. This is because there's a fan on the other side. It will push air through the case, cooling it, and this gives a place for hot air to push out of the back of the case. I didn't have room here to throw a second fan, so I just did a vent instead that I printed out on the 3D printer. Down below it, we've got the main power rotary switch. So when this is plugged in, you simply spin it to the right, and this will turn the entire system on. Down here at the very bottom, we have the power input for the main power control boards and for all of the different power supplies. This is where that power input comes in. And then we've got 4 status lights over here to show the status of the 4 different power supplies. And then we've got status lights for the 3 different relays here. I've got to write the labels on these still, but we got the very top is going to be the relay for the plasma cutter, the relay 1 and relay 2. Front end, of course, we got a nice Legacy 4x4 sticker there. And on the back side, this is a 120 volt DC fan, or sorry, 120 volt AC fan. And I think it's 140 millimeters, if I remember correctly, sized. But this pushes air into the case, bringing the cool air in so that it can come out the other vent. On the back of the case, we have the 2 hanging hooks here, which came with the case itself. I'm going to just weld some screws onto the side of the plasma table, and that's what I'm going to bolt these onto. And then up here at the top, you can see our plug connections. These are all of the connections aside from main power that connect to all the different parts of the machine. Over here at the top and down here, we've got the 3 big motors, the 3 big NEMA 34 motors, both the Y motors and the X-axis motors, and then we've got the 2 Z-axis motors down here. Next to it, we got the power for the relay 1 and relay 2 coming into the box, and then we've got relay 1 and relay 2 out. So basically you do a 110 volt plug, plugs into the in position of these relay plugs. that runs the power to the relays, and then the out will activate when the relay is activated. What that does is it allows me to control something like, say, a shop vac, or maybe a water pump or something like that, should I choose to put dust collection and or maybe a larger water-cooled spindle on the machine. That gives you 2 quick inputs and outputs for those relay controls. Over here, we've got the 8 different limit switches. So you need 8 because you've got the 2 on the y-axis, the 2 on the x-axis, and then each of the z-axis has their own limits as well. Next to it, we've got the Ethernet port. You can see you just unscrew it and there's an Ethernet face plug there. Of note, the Mesa manual does say not to use one of these. They say to wire it directly into it. I have not had any significant issues with something like this, but just a note that the manual does say don't do that. And down below it, this is the plasma hookup. Same thing, you unscrew it if it wants to come off. And you can see we've got the plasma hookup pin connector there. That is what runs the THC, as well as what runs turning the plasma cutter on and off again. Next to it, we've got the emergency stop switch and the spindle connections. And these are those. As you can see, a remote emergency stop switch. So if I ever had to do an emergency cancel on the machine, I've got that function now. And then this is what's going to get wired to the spindle, to the VFD of the spindle specifically, to control the spindle. And that plugs in right there and then is ran to the Mesa board. All right, moving around to the inside of the case. I know that this looks like a jumbled up mess. Like I said at the start of the video, I should have used a larger case for this. I did shove it. There's a lot of electronics inside this case. A lot of the other big brand stores or the big brand manufacturers of plasma cutters will run multiple cases to control something like this. You do usually 1 case to control movement and 1 case to control the plasma cutter itself. I wanted to consolidate it. And unfortunately, that just means that it's going to be a really crowded case unless you go to a really large case. I should have gone 1 size bigger on this. It would have made this a lot easier and would have made this a lot cleaner, but I didn't, and it's not. Anyways, so you can see at the bottom of the case, we've got all of the different power supplies that I've talked about before. And then in the center of the case, we have the Mesa 7i76E, as well as the THC-AD. And then down at the very bottom there, kind of underneath all the switches, we have the relays. And then we've got the 5 different motor control drivers up at the top of the case. The motor control drivers have heat sinks underneath them to help keep them additionally cool. Gecko recommends that in the use of the drivers. So I've got some of their heat sinks as well. And then the Mesa board and the THC, as you guys saw, have a 3D printed base on it just to get them up off of the very bottom of the case to make it a little bit easier to connect everything to. I should have done the same kind of thing like I did for the Mesa boards. I should have done the same thing for the relays, to bring those up a little bit higher so that they'd be easier to interchange if necessary, but I didn't. I don't feel like redoing this entire case just to do that, so we're gonna leave that the way it is. Like I said, it's definitely a little bit crowded in there, and it definitely looks like a mess, I'm sure. Again, I will put together a wire diagram, but I will also link in the description below this video a link to the LinuxCNC Forum that has a pretty good wiring diagram for all of this as well that you can see and look at. I will also link below in the description a video from MrRodW. He's one of the guys on LinuxCNC, does a lot of Mesa stuff, and he's got like an hour-long video discussing all of the ins and outs of Mesas and how to hook them up, how to set them all up, and then some of the other intricacies. It's a good video. It is really long and it's very dry, but it's a very good, very informative video. So if you're looking at taking one of these on, I would look at his video as well. I'm sure somebody could have done better cleaning this up in here, even in the smaller case, but oh well. All right, so I'm gonna end this video here, even though I am still waiting on that relay. I wanna get this video edited and out for you guys, and then I'm gonna clean up my shop and I'm gonna get started on the mechanical upgrades for the CNC. The biggest thing we're doing is going to be replacing all the motors with the motors that fit these pins from Avid CNC, and then also remaking the risers on the machine as well, to get the gantry up a little bit higher so they can fit larger things underneath it and give me a little bit more space for the router. And then I've also got to remake the gantry slider as well to mount the 2 different Z-axes that we have now at this point. But anyways, it's coming along. These things do take a really long time. It took me like a week and a half to put this thing together, working on a couple hours a day. just because it really is just a lot of leaning over one kind of step at a time. It is what it is though. It's very doable if you just go logically through the whole thing and kind of take it again one bite at a time, one step at a time, making progress through the whole project. But anyways, we got this done. The mechanical stuff should be a lot faster, and then I will show you guys another Mesa video setting it up on the new computer I'm going to use for this, so that you guys can hopefully have a better idea of how to set up Mesa, both to run a router and also to run a plasma cutter simultaneously. So we got a couple more plasma videos coming out on this as I continue to update this machine. Thanks for watching, guys. I know this was a long video. Thanks for sticking with it if you made it this far. I'll catch you guys on the next one. Take care.